Pardon me? Oh, okay. Okay, so he then received a PhD in math from here and went on to be a professor at University of Wisconsin-La Crosse. He was a very active researcher in mathematical biology and also very engaged in undergraduate research mentoring, including founding a summer undergraduate research program in math biology at University of Wisconsin-La Crosse. While at La Crosse, he began working in football analytics part-time and eventually wound up leaving academia and going to Pro Football Focus full-time. At PFF, he used his training as an applied mathematician to solve quantitative problems for 32 NFL clients and over 130 NCAA football clients, as well as numerous media clients. He developed numerous metrics that are now used on both the team side and the public sphere. He also co-hosted the popular PFF Forecast podcast. He still does some teaching part-time as an instructor, part-time instructor at Wharton and Data Camp. A few weeks ago, he started as Vice President of Research and Development at SumerSports, which is a very high-profile football analytics startup. Today, he will speak on From Football to Math and Back. Let's welcome Eric Eagert.
Well, first off, thank you for the very generous and thoughtful introduction, Richard. It has been and is an honor to be your student, even 10 years after I've got my PhD here. Yeah, so thank you all for coming. I'm going to describe kind of a very, I think, windy road, a very, circuitous path from my life as a football player in college to a math student here, a math professor, and then now in my current job working on football full time. Just a little shameless plug. I know Richard talked about my previous podcast. I have a new one coming out. I actually, for those of you that are on the Zoom or even in person that were fans of my previous show, the aptly named Printing Press / Syndicate, I thank you for coming to this as well. But if you're looking for your 15th podcast to listen to, that feels like a good one to start with. I'm going to first talk about my motivation for basically everything I do, which is that mathematics is an excellent means by which we can formalize information in a logically coherent way. If anybody's watched football, especially, and I'm going to take a few jokes here today, especially Nebraska football, you know that it's not a particularly well formulated, thing all the time, and it bears logically confining it into symbols and things that we're comfortable with dealing with. And because this has been successful forever, we've had success at various degrees in things like physics, biology, finance, maybe less so, and then I think even less so to this point, sports, using the language that we've been given to us for centuries by mathematicians. And despite this importance, I think that when we look at the things that we love, we have a hard time, unless we try, we have a hard time seeing the underlying formalisms in those things. And so for me, I just want to, say sports and their statistics are the reason I came here and are the reason I, got to, a PhD in math. I was so interested in football, in sports and specifically their data, that it drove me to major in math in college and then eventually come here. And then eventually I made contributions to biology because I love sports, and now I'm making contributions to sports because I ended up being good at math biology. So there is very much the why math is a very good question, and I think careers like mine are a good example of where it can take you as far as almost literally everywhere. This is a little bit about me now. I played at Minnesota State Moorhead. Ironically, we had the same colors as Nebraska-Lincoln, which is kind of funny. When I was there, I majored in math. I came here and I got a PhD in mathematical biology with Richard, and Brigitte ten Humberg was my other advisor, a faculty in the math and biology department. And then I got a job at Wisconsin-La Crosse after that. While I was at Wisconsin-La Crosse, we did kind of everything there. From a math biology perspective, we got 2 National Science Foundation REU grants. We had what was called a KERM grant, which is another undergraduate research grant. We built what was called the Math Bio Working Group, and we hosted, while I was there, 3 conferences in mathematical biology in the city of La Crosse, a conference that they still do now that I'm gone, which is fantastic. And in fact, the second REU site that they got was after I left, which made me feel really good knowing that they, that what we built there is still very much maintained. And then what kind of got me here is that I started I started consulting on the side. So it first started with the United States Geological Survey, which is in La Crosse, along with the U.S. Fish and Wildlife. And I was working on standard mathematical biology problems while I was there. And then eventually I learned enough what they now call data science to start working at places like Orca Pacific, and then eventually Pro Football Focus is where I eventually left academia to go. There's an example of me. I actually did play. I got on the field. This is evidence. This is a proof by contradiction, if you will, to the proposition that I didn't play. And I think in a very funny turn of events, and I honestly put this slide in here. The people that helped me set up graciously today know that this came in at the buzzer, but I remember that I had written this in my PhD thesis, and it goes to show you, kids, do not make predictions that far into the future, because this was pretty awful. And just like the backstory around this, like the last 5 college football games I played, we lost 4 of them by a combined 8 points, I believe. And in such gut-wrenching fashion, I never wanted to see a football again, and so I came here. And so 4 years later, I still thought that was going to keep me from working in football, which of course I was wrong, and what wasn't the first time, nor will it be the last. And this is my time at UNL, which I loved greatly. This is my time at UWL, where I was the math club faculty advisor, much younger, much more hair actually, and a little thinner as well. And then after that, so I joined Pro Football Focus in 2015, and basically there was it's honestly the most millennial story of all time. There was a call for people on Twitter who wanted to watch football games and get paid for them. And I thought, look, if I'm going to spend an entire Sunday making the rest of my family angry, I might as well get paid for it. So I ended up doing that. And basically it was like a writing / data collection job. It was really there was no analytics to it. But what was the real fun thing was they gave me access to their database. And so over the course of about 2 years, I started writing articles about player value and all these kinds of things that I figured were already solved problems in football that I was just doing for fun. And ultimately they weren't. There was all this data being collected. There was the what of the problem. And we were starting to crack the so what and the what if of these problems. And then I joined them in 2017 as a consultant. And I started actually building out, basically with my colleague, George Shahuri, I started building out basically all of the tools and things that NFL teams use and fantasy football players use and gambling enthusiasts use and things like that. And by 2018, I joined full time. And eventually they gave me my own department in 2020. And from there, we had built a group that, varied in size from anywhere from like 6 to 10 people, whether they were subject matter experts, data scientists, basically the whole gamut of people that can model football with math. And then, as Richard said, as recently over the past couple months, I left PFF and joined SumerSports in 2022. So now, and just a little bit of background on those companies. PFF was founded by Neil Hornsby, who is from the UK, and was unsatisfied with the way in which player statistics were not only collected but used in broadcasts. It drove him insane. And so he developed a system to grade players. I think that the legend is he literally did it on a piece of paper for a few games. He got a group of fellow people from the UK to sort of formalize that and put it into a system, 5 to 6 years before I showed up. And that became what PFF was, at least initially. And what's really cool about this, I think, as far as an anecdote for folks in here was, PFF started basically in the middle of the last decade, the middle 2 decades ago, so 2006-ish, 2007. I was an undergrad at that time, and and at that time, data science was really not a term, right? It really was not a career. And there was always these times, I dabbled in bioinformatics and, stuff like that, where people would say they would talk about careers as like, look, when you're my age, this career path isn't going to exist today, right? You're going to be working on something that doesn't actually have a foothold in the world right now. So just imagine in the future what you can end up being. And that ended up being exactly true for me. In 2007, there was no pro football focus. There was no football analytics. There was football analytics, but there was no, the way it is now. And there was no data science, right? And you fast forward, 15 years or so, and those are the key core elements of my life, which is extremely serendipitous, I think. And my mission statement at PFF was always to use data ingenuity to provide stakeholders with the best possible opinions with which to work. So this can be somebody who is, how many people watched the Kansas City Chiefs Las Vegas Raiders game last night? The people who are trying to make fourth down decisions, 2-point conversion decisions, use data ingenuity to make the best decision in that realm. If you're gambling on the game, like if you're a brave soul, use that stuff to give you the best possible opinion from which to bet, et cetera, et cetera. That was always my mission statement there. And we've taken it over, and it ended up being a very fruitful, experience. So this is an example of what the PFF website looked like right before the Super Bowl. So you had the Rams versus the Bengals here, spread, total, all that. You had, NFL stuff, betting stuff, draft, college, and we built this thing out so that football, fans, and they're, anywhere from like, I think, on the order of 10,000 subscribers or something like that, could enjoy the game at a deeper level. Again, a game that is only growing in popularity as we move forward. And then now I'm with SumerSports. SumerSports was founded by Paul Tudor Jones and his son Jack, with the goal of having the best-in-class quantitative analysis aimed at creating precision in player acquisition and roster management in the NFL. It's again right down. We were talking about how to make decisions with data. This was very much up my alley, and why I decided to join. The funniest thing is like rarely does the acquisition of a data scientist make its way into the Wall Street Journal, but ultimately this was the article on the day that I ended up announcing that I went with them. Frankly, I think like many people in the industry ended up finding out before like 9 a.m. that morning, which was kind of interesting, and certainly something unexpected for me. Again, we started this show here. This is the first episode of our podcast. Thomas Dimitrov is actually the CEO of SumerSports. He was the general manager of the Atlanta Falcons when I first started at PFF, and in fact, a lot of the stuff that a lot of the ideas that I had, came in consultation with Thomas once he left the Falcons, and obviously that relationship is, worked its way into this realm as well. So that's kind of like, my sort of path and how circuitous it can be, and how, when people ask, what should I do if I want to get into, football and data science and those kind of things, I say, well, I don't know if I'd follow my path, but that's the path that happened to me. Nowadays I'm glad to share, and I think UNL is in this realm as well. There's so many more opportunities for data science students, for students that want to work in sports analytics. I know 5 years ago when I was here, there was, I visited the sports analytics group at UNL, and it was, unlike any I've seen at a university in this country. So that's fantastic, and I hope that people who want to follow the path that I've taken have a much clearer road from which to go. What I want to talk about now is sort of what we do in football analytics and sort of the problems that we aim to solve, and our inspiration for doing them, and then where they're going to take us into the future. So this is a couple papers, or a book and a paper, that are kind of interesting, right? So firstly, this is Virgil Carter, who was a quarterback for the Cincinnati Bengals actually at the time, and a very sharp person. He, along with Robert E. Mackel, published this paper in 1970 called "The Operations Research on Football," and it was sort of the very genesis of going from a currency in the league that was based upon yardage, right? So you gain 4 yards on this play, going from that currency to going to the currency of what are called expected points. So basically, the idea that a 6-yard gain on 3rd down and 7 is worth differently than a 6-yard gain on 3rd and 4. One gets you closer to scoring. One makes you have to give the ball up if you punt on 4th and 1 to the opposing team. So they started that here, which is very cool. And then the 3rd edition of this book is coming out in the late 80s. Bob Carroll, Pete Palmer, and John Thorne wrote The Hidden Game of Football, which sort of, again, went through a few actual seasons of data and talked through sort of the methodology for trying to assign value to plays, which, again, as you'll see here, is the bedrock of everything we do end up, ultimately in football analytics now. Again, this is from last night. This is the Chris Jones sacking Derek Carr, stripping the ball from Derek Carr, and then getting called for roughing the passer, even though he held the ball. I think that's the first time in NFL history that has occurred. This expected points framework can tell us actually how bad of a swing that ended up being for that game. Furthermore, we have Brian Burke, who in 2008 actually, he did a little bit more in terms of formalizing this, which again, gave it the name expected points and expected points added. He used what's called a multinomial regression model, basically to spin out the probabilities that you score, any possibility in the game. So 3, 6, 7, 8, 2, -2, -6, -7, -8, and denoted those with probabilities. And then those probabilities were, you took the expected value of those probabilities, you ended up with expected points on a play. Brian deserves a great deal of credit. He's now at ESPN for pointing this out. And then it still, again, took the better part of a decade for this to really get the shine that it deserved. And that was when NFL Scrape R came to fruition. This was an R stats package, for those of you that are learning R, that scraped play-by-play data from the NFL feed and applied all these models to it. This was by a group at Carnegie Mellon, which included Maxime Horowitz, who works with the Atlanta Hawks, Sam Ventura, who works for the Boston Bruins, Ron Yurko, who works at Carnegie Mellon as a professor again, and this made its way all the way till 2019, and it eventually got improved upon. But this changed the game in terms of sports analytics, because you used to have to either, like Brian did, either work for a team or ESPN or something to get access to the play-by-play data so you could do work on it. This gave access to the play-by-play data to everybody who wanted it and who could do analysis. And a great story here was, one of my best colleagues at Pro Football Focus, Timo Riske, was a mathematics PhD student in Germany who really loved football. And in Germany, it's not as popular as it is here. So what Timo did was he would literally download this data and he'd do a lot of analysis on it, and he would just tweet it out to his followers on Twitter. And in a very wholesome diving into his DMs, I went in and said, "Hey, Timo, do you want to work for us one day?" And ultimately, he is now one of the people who is heading data science at PFF now that I'm gone, and a fantastic person, a fantastic opportunity that without this work and without the work that preceded it, a career in sports isn't made. So that's the excellent, excellent contribution there. And from there, we can do a ton of different studies there. So I showed you the Chris Jones sack of Derek Carr. You can actually look at how many points events in football are worth. So the most drastic one is here. If you get a sack on a quarterback, it's on average worth 2 points to 1.8, 1.9 points to the opposing defense, right? So if you take a sack as a team, on average, you're giving 2 points to the other team. Okay, so that penalty took 2 points away from the Chiefs and then added whatever the 15-yard penalty was, so you can imagine a big swing there. If you don't even get any pressure on the quarterback, the average pass play is worth about 1/4 of a point, right? So if you're an offensive line and you can protect the quarterback for 4 consecutive plays, that's worth a point. And we saw last night that 1 point is oftentimes the difference between winning and losing. All pass plays are slightly positive, and I'm not going to get into the difference between running and passing the ball. There's tons of frustration there by a lot of people, but running is generally speaking negative expected value. Passing is generally speaking positive expected value, just the cliff notes there. If you only hurry the quarterback, it actually doesn't do a whole lot to decline the straits of a football team in the passing game. If you hit them, it absolutely does. If you can hit a quarterback 6 times, that's worth a point. If you hit and hurry a quarterback, so there's a little bit of a weird distinction there. You can hit a quarterback as he's throwing without hurrying him, kind of weird, but and if you hit and hurry him, that's worth almost negative a third of an expected point to an offense. And all pressure, and that includes basically, that's just the linear combination of all these with the probabilities being how often they occur. All pressure takes about 2/5 of a point away from an offense. So being able to take all these things where it's just sack or no sack, pressure, no pressure, and actually assign point values to these things helped us, venture greatly into, the world of better understanding football. And additionally, so this article actually I published late last year, Pro Football Focus grades linemen. And, I looked at the difference between, and this was through a discussion with a team on a consulting call, we basically were arguing about which type of play was more weak link, basically. So which type of play was most dependent on the performance of the worst player, whether it was run or pass. And so I explored this, and it's run by a country mile, at least from the offensive line standpoint. And so I looked at this and I found a very interesting result, which was if none of the offensive linemen on a play screw up, if they all make their block, the average run play on those types of plays is more efficient than any play in football, which is really cool, right? Because for years, and I played tight end in college, and my coach, he loved the run game more than anything. Maybe it was because of me, but we didn't execute it very well, right? So we weren't that good. And what this showed was if you actually run the play or execute the play as it's drawn up, there's nothing better in football. That's exactly how they act. The problem is only about 35% of NFL plays are actually perfectly blocked. And so the average run play, because the difference between a perfectly blocked and a run play that has at least one negative blocker in it, a blocker who messes up, is about half an expected point. So you're basically chasing the best play in the world because of how beautiful it is, but it rarely can occur. You can rarely execute it. And that, again, why the run game, at least at the NFL level, is not as efficient, is not an efficient play on average, and not as efficient as passing. And this shows that distribution here. This shows a little bit, so this is negatives in the run game in terms of blocking. This is expected points added. You can imagine what a negative 10 expected point value play is. You're at the 1 yard line, you're expected to score a touchdown, so the expected points is 6, and you fumble and it gets run back for a touchdown. That's basically a minus 12-ish expected point play. So you can see that. These are like 90-yard touchdown runs. And so you look at the distribution, there's a ton of variance, but you can clearly see that the plays that are perfectly blocked give you more positive plays than those that don't. Then we made more, and when I say we, I say Ben Baldwin and Sebastian Carl made more advances here by not only making the NFL scrape-R package faster, but also adding to it a bunch of other metrics that people now can analyze. Things like win probability, things like what's called completion percentage above expected. So basically, given all these variables, how good is a quarterback at completing the passes he does throw, right? So traditional completion percentage is confounded by the depth of the pass a guy throws, right? And so if you can control for that and other factors, you can actually strip out, the scheme or what he's opting into, and really just look at his accuracy. All of that is in this really cool package. Again, for folks that want to get into sports analytics, this data is free, and it's every single play. I think all the way back to 2000, if I'm not mistaken. And this let us, really analyze the game, I think, at different levels. So this was my first year at PFF. This was the first time any of my work had ever gotten on TV. And this was, I think, week 1 of 2018. This is sort of a win probability model at the very beginning of opening day, with the Eagles, the defending champions at the time, against the Atlanta Falcons. That's basically the seed for what we saw last night, which again was Vegas 29, KC 30. So Kansas City is a pretty big favorite in that game, but the Raiders get a 17-point lead. They give up a touchdown. They get a field goal. It's sort of, you can see how the win probability oscillates. And then, of course, near the end of the game, when Andy Reid punted it back to Las Vegas, there was a small part of that game where Vegas was favored. And then Devontae Adams bobbled that ball, and the Raiders' drive ended, and the Chiefs ended up winning that game. So very, again, and all of this stuff, again, available to you, open source as well, due to the great community here. Furthermore, you can look at win probability in different sort of strata of data, right? So here's the aforementioned Andy Reid not going for the 4th and 3 from the 46-yard line. We can look and say if he went for it, he had a 72% chance to win. If he punted, he would only had a 66% chance to win. And if he would have kicked a field goal from that far away, he would have failed more often than not, but they still would have, because there's a chance it goes in and there's all these other factors, they still would have been favored to win, but not by nearly as much. And you can look and say, okay, where does all this come from? Well, it's okay. There's a 55% success rate when you go for it. If you succeed, you basically win the game. You have to get maybe one more first down. If you fail, you have a 56% chance to win. And the difference between 56 and 54 is the distance of a field goal, which is 7 yards. And that has made its way on a broadcast. Now, I don't think this slide showed quite as well, but again, this was in a Packers-Vikings game on Sunday Night Football. Again, the win probability is converted there. This was a Colts-Packers game where I was, at the time, literally on the phone with Troy Aikman's producer, giving them these numbers. I did this for 12 games that year, and this is the only figure that got on TV. So it just shows you the ROI on something like that, at least from my perspective. But it was fun to see, for sure. And the Colts converted that and won. So I felt really good about that. Additionally, you again see not only, so you can take it at the game level, you can take it at the play level, you can take it at the season level. So we would simulate games and send it into Football Night in America, which was again a preview of Sunday Night Football. And what was really cool was in 2020, as everybody remembers, the 2020 election was incredibly contentious, and my friend Steve Kornacki was on the TV for 6 days straight. Probably went to the bathroom twice. As a result of that, in the 2020 fall, they wanted him to do a similar sort of election style analysis of who is going to make the playoffs. So again, if you ever want like the exhilaration of your like math and your simulations being in front of millions of people at a time, this was literally us like in a Slack chat sending CSVs of probabilities to him as like the games would conclude, and like these numbers changing, these colors changing. It was really fun. I think they're still going to do that this year, although I won't be a part of it. But yeah, very fun like application of, again, all of these all these paths. And again, now that we had built now all of this formalism to understand, value in football, what a play was worth, what what actions were worth. And the next logical step was to talk about what value players were bringing to the field every single game. And we were not the first to come up with WAR in football. Ron Yurko, the aforementioned from Carnegie Mellon, had a WAR model for quarterbacks, running backs, and wide receivers. I believe this is the first one that did every single player in football. And this was published at the MIT Sloan Sports Analytics Conference. We did not get to present here because it was infamously on May 7th of 2020, which we all know what happened there. I believe that was the first ever flight I ever just didn't go on. I didn't cancel. I just didn't go because we all knew what was going to happen in the subsequent weeks. But yeah, so we modeled wins above replacement, which is a value that quickly caught on. This is again on Thursday Night Football. Julian Edelman had been suspended that year. We were able to talk about, okay, if he comes back to the Patriots, where are they in relation to the Kansas City Chiefs, who at the time were the leader in the NFL? Patriots ended up winning the Super Bowl in this season. And we said, okay, Edelman, and again, this number actually evolved over time, but at the time, our estimate for his number of wins for the remainder of the season was about 3/4 of a win. And so that was used on one of those broadcasts to try to conceptualize his impact. Here's Peyton Manning, who for my money is probably the best quarterback to play during the PFF era. And again, here's sort of his absurd wins above replacement numbers. He was worth 6 wins, which everybody, NFL season at the time was worth 16 games. So he's an incredibly imbalanced amount of his team's wins when he was in Indianapolis. He missed the 2011 year with a neck injury. He goes to the Broncos. He makes a Super Bowl in 2013. He also won a Super Bowl in 2015 by playing incredibly poorly, which just shows you that life and football are a team game. But this is, again, kind of like what a team would look at if they were trying to look at PFF's wins above replacement model. And then lastly, like this is kind of a cool story, and I have his permission to talk about it, but this was like my first month or so at Pro Football Focus. I get a message from somebody that I knew from a team, and they say, "Hey, what is so-and-so's war?" In this case, it was Ricardo Allen, who ended up finishing his career in Cincinnati, became my friend, and I told him the story. Ricardo Allen, I go to his analytics person, I give him the wins above replacement number, and 3 days later, I look at Twitter and I see that now he's worth, tens of millions of dollars, and I'm like, okay, this is pretty fun. And obviously, Ricardo was somebody who was an undrafted free agent, so he did not make millions coming out of college. Worked his way into a starting lineup, started a Super Bowl, played in last year's Super Bowl for the Bengals, and a very good player who ended up getting ultimately what his market value was here, which is very cool. And so that's kind of, again, that's kind of, where it has been. And a lot of those problems, I'm not going to say that they're solved, but we got a good grasp on them. Now we get to some of the fun stuff. Again, this is where we're going now with basically all sports, but also specifically football. And this is tracking data. And this is an example of what tracking data can look like. It's basically for every second, there's 10 frames of data on position, orientation, speed for a player. And so football, which had traditionally been, as you can all imagine, row poor and column rich. There's a lot of things to denote, but there aren't that many plays in a game. Now we just multiply for every single player, however many seconds there are times 10, more data onto that spec. So that increased our ability again to really understand the game of football. And we collected this in a few different ways. So NFL, and I say we as in like the community, not me. The NFL started putting RFID chips inside the shoulder pads of players. There are companies like StatsBomb and others, Sport Logic, that are using what's called computer vision to basically take broadcast data and come up with this granular of data through what's called computer vision. And then there are also, for sports like basketball and soccer and things like that, there's also optical tracking, which is, again, lining up cameras actually in the stadium through that third party to collect that data. But what that gives us is better data, but also a humongous collection of problems from which to work. And this person, Michael Lopez, who runs analytics at the NFL, gets a ton of credit here. The NFL, once they released this data in like 2016 or 17, in 2018, he started what's called the Big Data Bowl, which is basically a hackathon for NFL fans that goes from basically right now, like they just opened it up this year, all the way until the Super Bowl, and the winners the winning groups get a trip to the NFL Combine to give out their results to the NFL teams. And dozens of people from this competition have jobs at either Pro Football Focus or Sumer or NFL teams, or some combination of them, which is wonderful. And it also helps us solve bigger problems. So what's really cool is there was a decision the other day where our discrete classification of down and distance, so 4th and 1, was not sufficient necessarily to denote the probabilities of making a first down. However, the tracking data allowed us to use sort of more granular, it was like 4th and 1.7, and that was the sort of theme of this paper by Lopez, which is basically saying if you have this granular tracking data, you can make better predictions about you can basically split the difference less in your inference and prediction problems. And it was a very cool paper, and it's already making its way into sort of where we are in terms of understanding the game. It has, one of the big data bowl solutions actually made it into the broadcast. Like I think it was the 2020 was rush yards above expected. So basically, if you just take all the players on the field at a time and you run like a neural network model, you come up with the number of yards you should expect to gain on a play. And then the number of yards that are gained above that are rushing yards above expected. This is something like a 95-yard touchdown run by Derrick Henry that was expected to gain 6 yards, gains 95. It's 89 yards above expected. And again, this is making its way onto NFL Network and the various broadcasts, which again is a very cool use of this very granular data. My group at Pro Football Focus, we also have worked on this as well. This was a finalist in last year in 2022's Sloan Sports Analytics Conference, using charting and tracking data to better evaluate players. Some of the things that we worked on were, how do linebackers move when you fake a run play, and how much space and how valuable that space is that they vacate is equal to. And we found a very very cool result that how much you bite on play action relative to expectations is a trait. So it's stable year to year. If you do that one year, you're going to do it the next. But it also, and this is reminding me of my math biology days, there was a humongous trade-off in it where the linebackers that do a pretty good job of retreating on play action do a poor job of flowing against the run. So this play basically makes a linebacker choose what kind of player they are. Are you aggressive or are you not? And you can use this kind of data to profile a player. Now, there are some unicorns that are very good at flowing to the run and are very good at not biting on play action. But those players are incredibly valuable and to these plays and also very rare. We also use that data to basically take the NFL scouting combine and see if we can replicate some of it with on-field data. So this is for pass rushers, so people that try to sack the quarterback. And there's various sort of combine metrics. So how high you can jump, how fast you can run a 3-cone drill, and how fast you can run a 40. And we have this basically expected pressure rate, which is how fast you get off the ball, basically will dictate what the likelihood is you get a pressure, and all of these things. So the slower you are, the less likely you are to get pressure on a play. And this is how slow you are when you came into the league as a rookie. So this time is basically stays with a player their entire career, whereas this is time varying for a player. You get slower as you age. And so obviously this number is going to be preferable to this because you can talk about a 30-year-old player and stop using the time that they had when they were 23. Additionally, if you look at the color here, these are, darker colors are bad vertical jumps, less explosion. You see more of those here than you do here. And then smaller dots are faster 3-cone times. You see more smaller dots here, and you see more bigger dots there. So you are replicating, the athleticism that players end up showing on the field through the tracking data. And at one point, I think the prediction is that it'll eventually replace all of these 40-yard dash, 3-cone drills, vertical jump type of metrics. And then this is really fun. A wide receiver for the team that my favorite team, Marquez Valdes-Scantling, he was the only one that he was a free agent last year. He had almost all these bad metrics by PFF, my own company at the time, and he also had he had some issues that caused him to be a free agent. I was very happy that the Chiefs signed him, because when I measured speed on the field, he was one of the fastest wide receivers with the ball in the air through this. And again, we would never be able to mark this with manually. And so it was very cool to see that when you build a metric, 9 out of 10 players are the ones you expect, right? So Cooper Kupp and all the Super Bowl MVP and Offensive Player of the Year last year, Randy Moss, Antonio Brown, all that. And then you have the one guy that stands out, and maybe he's a hidden value to teams. And all of this ended up being, a part of this, sort of projection system we built, for players at PFF, which was, again, a very fun exercise in sort of scenario planning. So this is Justin Herbert. He's the quarterback for the Los Angeles Chargers. I took this, a long time ago, actually, probably before, all the 2022 data was starting to come in. And basically what you can look at is like, hey, let's simulate his career, or at least his season, with various levels of pressure on him, with various levels of play action rate, various levels of quick throw rate, play action rate, and so forth. And that really allowed us, because we had a lot of inquiries about, how does this player fit into my team? Football is a very scheme dependent game. And ultimately, we built this system so that teams could go in and actually fiddle with what they wanted their scheme to be or what their scheme was, and end up getting projections for a player, like how valuable he'd be, what was the upper tier, how often would you play him, so on and so forth. And building out distributions so that you can see sort of when a player ends up being Patrick Mahomes, for example, what percentile outcome was that really in general. And, and again, this is very, early on, but I'm kind of looking towards the future here a little bit with this. But this is what's called text analytics, which is, again, looking at, open source things that are written on the internet. So this is from Dane Brugler's scouting reports for The Athletic on Justin Herbert, and basically taking that text and then other texts that you see from other scouting reports written, using what is called latent semantic analysis, and trying to find similar players in the database as him. And what this came up with, for Herbert, was a player that I wasn't really high on when he came out, because his traditional stats at Oregon were just okay. But when people with a trained eye, a scouting eye, were looking at him, they were, and again, this is just one of the scouting reports we use, but they were comparing him to guys, Kyler Murray was the first overall pick in the draft. Now he makes one of the richest contracts in football. Josh Allen is probably the MVP of the league this year. Lamar Jackson also won an MVP. We'll forget about Josh Rosen for a second there. Baker Mayfield was the first overall pick. Marcus Mariota was the second. So what people said about Herbert, they were also saying about these other quarterbacks that were well regarded and also had various levels of success in the NFL. And again, this is kind of, there isn't a product that does this. This was mostly my sort of the academic in me sort of wanting to build something like this and see if I can understand the game better. But again, I think the future is going to be in sort of leaving no stone unturned as far as data science techniques in understanding the game. Okay. And lastly, what I want to talk about is, and I do want to, again, compliment UNL in this way. And I talked a lot here about a lot of other people's work, because we all owe a great debt to people who have come before us, who have worked with us, who have inspired us to do a lot of great work. And so obviously I wanted to, shout out a bunch of people and their work here. But what I really thought was great about my time at UNL was the community that we built and the mentorship that people had here. And, I told Richard this last night, so I was able to get it out without crying, but I said, you learn how to be a mentor by having great mentors. And when I was here, there were not that many unhappy graduate students. There were not that many graduate students that didn't feel like they had what it took to get through. And there were various levels of ability in our building, but everybody had a purpose. Everybody had kind of the people that believed in them. I thought it was immensely valuable here. And like, once I got to, UWL, I obviously had the RU site there. And then once I got into football analytics, I wanted to say, okay, well, there's, football is this discipline slash, workspace that isn't always the most accessible. I'm 6'3", and I played tight end. And so I kind of looked the part, and even me, like I get called, I get called all kinds of names for trying to come into football as a academic slash data scientist. So you can imagine what it's like to be, in another underrepresented group and so on, or an actual underrepresented group as opposed to me. And so what I wanted to do was to build a community through giving people opportunities to get into sports. And one of it was through my internship program. So this was my 3 interns at PFF this year, Haley, Arjun, and Judah. And this was their last picture in our studio at the end of the summer. A few of them helped the Michigan Wolverines win the Big Ten title, much to the chagrin of probably Husker fans in here, which is great, through some of their analysis tools and just their overall. I mean, Michigan actually has a fantastic collection of people, young people working on sports analytics, and I've gotten the pleasure of having 2 of them as my interns. And I also, my intern from 2000, including and Tej Seth is somebody I can't go without mentioning. one of those Michigan students. And then one of my students from 2021, Zach Drapkin, ended up getting a job as a quantitative analyst for the Philadelphia Eagles. This was me visiting him while I was teaching a class this summer. He's not going to take any credit for the Eagles being 5-0. I will, though, for him. But that was really cool. And again, we just, my thing is, this is a vehicle, sports analytics and math in general. And I know that this was always the thesis of UNL. Sports analytics is a vehicle in which we can give people opportunities to get involved in sports that wouldn't otherwise have them. And so we started actually in the Cincinnati area because PFF was in Cincinnati, and obviously you have 3 sports teams. My friend Nick Wan, who's the director of analytics for the Reds, and myself, of course, we started doing sports analytics meetups. And a few of them are going to be at restaurants or bars, and then we actually had one at the University of Cincinnati just a month ago. The next one's going to be at the University of Xavier. And again, there's a ton of interest in this. A lot of people come, and there's tons of interest in other cities as well. And I think, again, this is just one of those things where this is a vehicle for people to learn mathematics, which would help them in any industry, but also get into sports, an environment that has not always been open to people. And then I think this is like, I don't really want to, this is the one of the crowning achievements of our community as well. This is Kwesi Adofo-Mensah. He is the general manager of the Vikings. Prior to that, he was a quantitative analyst for the 49ers and then a VP with Cleveland. So again, the Vikings are 4-1. I don't really want to jinx it at all, but he's considered the first analytics general manager in the NFL. And so I would be remiss not to mention him as well. Very proud of the community, but also obviously him as he made that jump this year in January. So that's basically where I'm at now as far as the talk. I do want to give out some unsolicited advice to folks as far as what to do from here, because it's obviously I gave out a lot today, but I think the biggest one is this communication skills part. Like, and what I really liked about UNL as well is like we talk math all the time, right? And we talked about our ideas, and we talked about we had to defend our ideas, and we had to they had to stand the test of time. And you may think that somebody like Richard Rebarber is a real stickler about those proofs that he's giving you. But if you walk into a room with somebody who's worth a few $1 billion and owns a football team, it's going to be a lot. It's going to be a similar challenge. I'll just say that. So communication is a huge thing. Programming, learn more math and stats than you think you need. This comes back to my thing of the jobs that a lot of you have will not exist today, right? And so you're not going to know. You're going to be like, oh, I don't want to do abstract algebra. I'm never going to know. I'm never going to use that stuff. Like like I said, like I said that football was not my optimal path. Like I was wrong. You're probably wrong about what math will be useful to you in the future. And the last thing, apply for things for which you think you're unqualified. There's always going to be like a little bit of nervousness there, as far as whether or not people are going to take a chance on you. I think people are going to take a chance on you in the future, though, especially given the growth of data and all of that. There's where you can find me on social media if you want to. This is my email if you want to shoot me an email. This is the course that I have on Data Camp, Linear Algebra for Data Science in R, which you can, I believe, like it takes like 4 hours to take. So I feel like it's fairly easy. This is my my book that's coming out with one of my best friends, Richard Erickson, who's actually still a mathematical ecologist, but wanted to write a book with me. And so we're writing football analytics with Python and R. The first 7 chapters are actually available on O'Reilly Media. We're not finished with it yet, but you can look at a draft of the first 7 chapters on O'Reilly's website. And lastly, thank you all for coming.
All right, so we do have some time for questions. So we are going to ask that if you have questions, you use one of the mics. Just make sure that we can pick up the audio on Zoom. So for those of you who are joining us via Zoom, feel free to type those in the chat. or Q&A. And then if you have questions, you can come up to one of the mics that we have in the room or raise your hand and I'll come to you.
So I guess one of my first questions, just looking at all the different analytical ways that you analyze the game. And one of the first things that came to my mind was how like data in previous history has affected games like chess. And how is that possible in football? Like say, if everything goes right, this play versus this play, what is the success rate?
No, it's a great question because, I don't know much about chess, but I do know a little bit more about like basketball and baseball, for example, right? So basketball and baseball are probably, I don't know, a decade, let's say, order of magnitude ahead of football, right? And what you've seen in baseball is like analytics showed the value in being able to predict the 3 true outcomes: strikeouts, walks, and home runs. And so, now you have players who are optimized to hit a lot of home runs, but then obviously the trade-off is more strikeouts, right? And so the game has become like maybe a little bit more boring. Yeah, to certain people, the game has become a little bit more boring. In basketball, there are more, people, they basically just did an expected value problem, but they found out that 3s were more valuable than 2s, right? So you see you see a guy like Al Horford, who was like a center when he got in the league, never shot 3s, develops into a guy who can shoot 3s because they're immensely valuable. You look at shot charts now, and there are hardly any mid-range jumpers. Like it's changed the game significantly. I imagine, chess is a little bit different because I think it's a closed system. Again, excuse my ignorance, but it might not be as like able to shift right with analytics as maybe as some of the sports. But what I find the most exciting about football and sports in general is like all it does is change the problem you're solving, right? So if we change, if sports analytics changes the game and it becomes a totally different game, then all it does is generate more problems to solve, right? And that generates jobs for people. That generates, opportunities to reevaluate what you thought about the game. So I said running is less efficient than passing. Like I don't think this will ever be true, but what if defenses just play so pass happy on their side of the ball that running becomes more efficient? Well, then you got to change all your assumptions about the game, and then it's back to being a different math problem. So I think that to me it excites me more than anything, because again, it means that we'll probably never solve sports. We're just going to change them, and then we're going to solve the changed game, and then we're going to solve the next changed game, and that's pretty cool in my opinion.
Thanks. That was a really interesting talk. You made a comment earlier about profiling players. Do you think and that's more the general, you as analysts have a responsibility to make sure that these kind of tools for profiling and digging up all possible information on players remain in sports and don't, wander out to more nefarious agents? And do you have any ideas how you can make sure that that doesn't happen?
Yeah, like the first text analytics, one of the first text analytics explorations in football was actually trying to uncover racial biases in quarterback evaluations. Like that 100%, that is a thing that can certainly be harmful. So yeah, there's a lot. There obviously could be more care taken to it, but yeah, that is something that like the ethical aspect of data science in general, it always has to be considered.
You talked about, some like super analytical stats, like expected points added. What are some of the raw stats that kind of go into there and like help the expected points go up?
Yeah, so like generally speaking, for like expected points, you have like the value of the next score, which some people don't necessarily, there's actually debate as to whether or not that needs to be the actual response variable. And then it's just like down distance, yards to go, whether the offense is the home team. Like it's actually a relatively simple model when you break it down. And then you feed those into a standard, multinomial model. And then that gives you the probabilities. And then you sort of know, okay, if it's 1st and 10 from the 25, the next score is us scoring a touchdown with probability 10. And it's us scoring a field goal with probability 25. It's us punting the ball and then them scoring a field goal, which is -3, is 20. And then you sort of take the expected value over those numbers. And then that gives you that value.
All right, this is a question from online. So how correlated would a master's degree in accountancy be when it comes to sports analytics and attempting to find a role within an NFL franchise?
I don't think that this sounds weird because I've just, I do believe that there's a ton of value in math education and all that. Like, I think though that if you do get a degree in something else, like one of my best friends, but also one of the best people that I had at PFF was not a math major, was not a stats major. I think took one stats class in college and is one of my, one of the better data scientists in the space. Like, you can absolutely learn these things. Almost everything I learned in doing all this work, I learned after getting a PhD, like on my own. So I don't think that the roads are closed to anybody, really. It's obviously a lot harder. And if you get a PhD in math, I told some of Richard's students this yesterday, you get a PhD in math, your habits of mind are going to give you an edge. But just because you don't have one doesn't mean you're not going to have a chance.
Can you talk about terms of spending, how PFF and your company with that you're now helps clients model spending? I'm super interested. A number recently leaked out, which is the first time ever in Formula One, with the cap that Mercedes said that Red Bull violated their spending by $7 million, and that was equivalent to 0.025s of a lap time per second. And they actually leaked out how they were modeling that as well. So how does that translate to the NFL?
I can't get too much into the details, but I'll just say this: like, one win above replacement for a non-quarterback is worth about $50 million to a team. So you take like a classic one is Aaron Donald was worth one WAR last year for the Rams. So that on-field value is 50 million. So when he made, I think he made something like 25 to 30 last year. So he's earning the Rams 20 to 25 million in surplus value. Like, that's kind of one of the calculations you make. Or, you have somebody like, the biggest thing in the NFL now is that, the NFL gives a rookie wage to players based upon when they're drafted, and they are not allowed to get a contract extension for more money until after their third year. So when, Kansas City, for example, they draft Patrick Mahomes, he's worth, he's worth $50 million. He's only being paid $5 million. Now you have a $45 million surplus that you can spend everywhere. You're like the New York Yankees at that point. And that really helps. Whereas, Green Bay, and there's a lot of Packer fans in Nebraska, like, they're paying Aaron Rodgers $50 million. He might be worth that, but then he's got no surplus. So then you can't make mistakes everywhere else in your roster, right? So that's a little bit of a kind of a flavor as to what those problems look like.
So speaking of Mahomes, this question comes from chat. Is Mahomes a 2.5 mortal this Sunday?
Say that again.
Is Mahomes a 2.5 mortal this Sunday?
Okay, so that's referring to the bet. When I worked at PFF, we would give out gambling advice on the podcast, and the classic bet every single week was Mahomes over 2.5 touchdowns, which I don't think he's a 2.5. I think he's going to throw 3 or more on Sunday. Let's just give that one out for everybody.
When you're talking about the probability of a play like succeeding, how hard is it to differentiate like the skills of the actual player, like doing, like, actually performing to their best in that play?
Yeah, I mean, that's the thing. Like, so, a lot of people are going to say, well, what do you so most of these models take into account a lot of the factors you can think of. So, for example, like the model that we had at PFF took into consideration how good the run defense was, how good the pass defense was, how good the run offense was, so on and so forth, weather, that kind of stuff, whether you're in a dome, what the wind speed is, all that stuff. Some are a little bit less, they have less features, but the numbers are still pretty similar. So my take is like, look, most of the time when a coach says, yeah, this is what the number said, but I knew this about the play beforehand, so that's why and it's almost always to be conservative. It's almost always to punt or kick a field goal as opposed to go for it. I think, there are obviously subject matter expertise that go into, in-game decision-making. I think for the most part, though, they're almost always overestimated and biased towards being conservative.
Okay, so it is past 5:30, so we'll just take a couple more questions. So I'll take yours in a second. I know this gentleman had one.
I was curious about just, you said being a fan yourself, how that work that you're doing affects just your fandom of football and other sports.
I I don't know. I'm very good at compartmentalizing. Like I went and saw one of my friends last night in Omaha, and I watched the Chiefs, and like that's the team I like the most. And I was able to like be a rube for a day. You know, like it doesn't bother. Like I certainly get angry at some things that teams do, but for the most part, like I have an orientation towards football where if I'm not like romantic about the game, like I just probably should do something else. So I try my best to like stay a fan, even though you know there are obvious implications to doing that. I think I'm fairly good at compartmentalizing them.
So what can you say about like the randomness of football as compared to like the randomness of hockey or like the randomness of basketball? And what would you also say is like the most applicable theoretical math skill to the area of data science and sports analytics? Yeah,
so Michael Lopez, who I shouted out here, he did a study, Michael was a professor at Skidmore before he went to run data science at the NFL, and prior to that, he was a football player at Bates. So he has like all this cool background too. He basically said, you know, and I think it was like series size. So like, what is the series length that you would need to simulate to basically make sure that the best team won a series without much variance at all? And it always came down to hockey was the most random. Football is a little bit less random. And then as you got into like basketball, a 7-game series in a game with 200 possessions, that's the least random. So the most often a game of basketball, the better team wins. And then so it kind of goes down in it kind of goes down there. Football, as you can imagine, there's 200 plays. The ball is kind of weird. I was talking to Richard about this last night. Like a touchdown takes you from being up 0 to up 7, whereas like the biggest jump in basketball is 4. You know, the biggest jump in baseball is 4. Like it's just, you know, there are things that you can sort of look at these games and say, okay, how many scoring chances are there? How many possessions are there? And you can kind of deduce from there the inherent randomness. But you know, hockey is the most random. It's almost like you shouldn't even play the regular season, or you should award the team who like had the highest points during the season. You should award that team the champion as opposed to the rigmarole that is the Stanley Cup playoffs. But as far as theoretical math, probability is the biggest one. Like if you understand probability pretty well, I think like this stuff is going to be not only easier to do, but more fun too.
We'll do one final question from chat. So we know you discussed programming platforms like R and Python. Would those be the most imperative to learn?
At this point, I know I said it in my slide that you can learn I think if you learn C++, you're probably gonna be able to learn Python and R, but yeah, right now the two most ubiquitous languages in data science are Python and R. And I think they're basically like, you know, pick them on a neutral field, basically.
All right, well, let's thank our speaker again.